In the previous chapter, we have seen the C++ programs, which are not based on classes and objects. I had just introduced you the similarity between structure and class and similarity between structure variable and object. From this chapter onward, I would like to discuss the concept of object-oriented programming, classes and objects in detail. Just like a structure, the class is an user-defined data type. The concept of class is an extension to concept of structure. Let us see the structure. We have already discussed this issue many times. I am just revising the concept of structure. This is a definition of a structure. While defining it, the struct, this keyword is used. We have defined a structure, namely SAM. These are the data members of the structure and they are valid data types. After that, using the tag of the structure, this is the tag of the structure, and using the tag of the structure, we can create structure variables. So K is a structure variable of structure, namely SAM. In short, this is a map of a building. Using this map, we can create same types of buildings. Is it clear to you? Let's study the concept of classes and objects. This is the class definition. This is the class keyword of C++ language, and SAM is the name of the class. We know that in structure there are data members, but in class, in addition to data members, your class contains member functions. There are two types of members of the class, namely data members and member functions. You see, here integer a is a data member of the class, namely SAM, and initialize and display, these are the member functions of the class, namely SAM. If you want to see this one diagrammatically, let us see this diagram. This is your class definition. Using the keyword class, we have created a class, namely SAM, in which there are two types of members. First one is data member and second one is member function like initialize and display. Is it clear? Using this class definition, we'll create objects. So K is an object of type SAM. K is an object which is an instance of class SAM. So this is a map of a building. Using this, we have created a building, namely K. So using this map, namely SAM, we can create a number of buildings. Is it clear to you? Well, now let us see the next part of the program. So after defining the class, we'll create an object, say K. So SAM K, this will create an object, namely K. Read the next statement. K dot initialize in the bracket 100. Here we are calling a member function, namely initialize, of the object K. What we are doing? We are initializing the data member of the object K, namely A. You see, this is your data member of the class SAM, namely A, and this initialize member function will initialize this variable A, this data member A. Is it clear? Let us execute the program up to this step. Press F4 key and now press F7 key and observe carefully. Control has jumped to the member function, namely initialize. What is the value of K? It is 100. We have passed 100 to this function. Execute this one. The value 100 we are assigning to the data member A, and after that control will come back to the function main. Is it clear? Now observe next step in this program, that is k.display. We are displaying the content of the data member A of the object K. Press F7 key. Control will jump to the member function, namely display, and you see cout statement is displaying the content of A. Press Alt F5. See, 100 is displayed. Let's study one of the very important concept in C++ language, that is access protection and data hiding. This one is the key concept in OOPS. Have you noticed one interesting thing in this program? I have used a keyword, namely public. What is the importance of this public keyword? You see, I'll show you first demonstration and then we'll study the meaning of this one. Here I have written a statement cout less than sign means insertion operator, k.a again insertion operator, and end L. Remove the comment mark from this statement. Press F9 key. There is an error message. Let us see what is that. A is not accessible. So this is the resolution operator. SAM resolution operator A is not accessible. Let us see what is the meaning of this one. Observe very carefully. In this class, I have written integer A semicolon. I have not specified any public or private keyword. Remember that by default in C++, in the classes, the data members and member functions are private in nature. What is that? By default, members are private in the classes. So that is why this data member is a private data member of the class SAM. Hence, from outside the class in the function main, we cannot access k.a like this. And that's the reason behind the error. Let us study this concept with the help of diagram. That is the concept of access protection and hiding data from the outside function. Suppose this is your house, this is the bedroom which is private, and this is the drawing hall which is not a private area. We can enter inside the drawing hall. These are the public member functions, means members of your family. The members of the family can go to the bedroom and they can use the fridge. But directly we cannot go to the bedroom and open this fridge. For outsider, the entry is banned. Only member of family can access it. In other words, you observe very carefully, this is A. The access of A is private. So this is private data member of the class SAM. These are the member functions. I use public before this member functions, and that is why from outside the class we can access these member functions. But k.a is not possible because it is a private data member of the class, namely SAM. Access to private members from outside the class is not allowed, and that is why you observe this root. I have put a cross mark over here. This is not possible. We cannot access the data member A from outside the class, that is from function main. Is it clear? These two are public in nature. So access is public, and hence we can access them from outside the class like this. So using dot operator, we can access these two functions. Remember one more very important point. Member functions can access data members of the class. Any member function of the class can access any data member of the class. And that is why initialize function can initialize this data member, and display function can access it and can display the content of A. Directly if you try, then you won't get any result. Compiler will generate an error message Now that is why we got error message in this statement. I hope that you understood the meaning of public and private keywords. These keywords are used very extensively throughout the C++ language. In this modified version of the program, I have used same definition of the class, namely Sam, and I have created three objects K1, K2 and K3 using the class definition of Sam. K1 has data member namely A, K2 has data member, again name is same, that is A, and K3 also has same data member, that is A. But remember this important point. K1, K2 and K3, they have independent copy of the data member namely A. Now I am initializing A, that is data member A of K1, and I am displaying A of K1 object. So let us execute the program up to this and see the output. 100 is displayed. Now second step, I am initializing the data member of the K2 namely A. I am assigning the value 200 to it using the function initialize. Execute it and display it. What is the value? Let us see. 200 is displayed. Well, in third step, I am initializing the data member A of K3 object and passing a value 300 to it. So press F7 key. I am initializing this A. Press F7, again press F7, and now execute display function. Press F7 and press F8. You see the output, 300 is displayed. Have you understood this concept? Let us see the diagram. Sam, K1, K2 and K3. This statement is creating three objects K1, K2 and K3. Each of this object is having its own copy of data member. Is it clear to you? But remember one very important point. Member functions are stored at only one place in the memory. Data member, K1 has its own data member, K2 has its own data member, and same with K3. But the member functions, copy of the member function is only one, and it is stored at only one place in the memory. You can access these functions from K1, you can access these functions from K2, and you can access these functions from K3. But separate copy of the function is not supplied to K1, K2 and K3. Is it clear? Understood this concept?